All right, so this week we are going to start by looking at section 1.3, which is on functions. So you're going to see a little bit more with domain and range, and that's kind of something that's going to come up all year. So we're going to do a little bit more. We'll do some stuff by hand, and we'll do some stuff on the calculator as well. So just kind of a reminder about a problem that we did at the end of section 1.2. It was the rent-a-car problem. And there was I think it was a $15 fee to book the car rental, and then you paid 20 cents for every mile you drove the car. People remember that rent-a-car problem we did? Okay. So we have different names for the X and the Y variable. And in that section, the two names I mentioned were independent and dependent variable. Does anybody remember which letter there is the independent? Yep, Jane.
X.
Yep, X is the independent, and Y is the dependent. Besides calling them independent and dependent, there are other names. You can call X the input and Y the output. You can also call X the domain, and you can call Y the range. So the word domain is going to come up in the context of a problem that says, like, find the domain of this function. Domain is basically any numbers that you are allowed to plug in. There are two situations that can come up that we need to avoid, and I'm going to show you what those two situations are. Okay, so what makes something a function? So for something to be a function, there's a test it has to pass. You might have learned this. It's the something line test. Does anybody remember the name of that test? Vertical line test? People remember that? Some people a little bit, not as much. Okay. Well, that's a kind of a visual way, and I'll talk about that towards the end. But basically, what makes something a function, if you don't want to think about it using that what's called vertical line test, is it's that when you plug in a number to a formula, you get exactly one answer. That's what makes something a function. You plug in one number, you get back one number. Right? So what's an example of a function? Let's say y equals 2x plus 3. That's a function. If I plug in 1 for x, what's the answer that I get for y? Yeah, I get 5, right? And that's the only answer. You don't get maybe 5 or 7. Nope, you only get 5. What about if I plug in 10 for x? I get 23, and 23 is the only answer. So for every x value that I plug in, I get exactly one answer, one output. So that's a function. That's good. Here's something that's not a function. Y equals the positive and negative square root of x. If I plug in, let's start with 9. If I plug in 9, what number can you multiply by itself? That's the square root. What number can you multiply by itself that's positive and gives you 9? 3. So if you plug in 9 for x, one answer that you get for y is 3. And then what number can you multiply by itself that gives you 9? That's negative. Negative 3. So the problem here is if you plug in 9 for x and you take the square root of 9, there are two different answers. One of them is 3, the other one's negative 3. This is not a function. This is a function. Okay. And I didn't write the ones down we plugged in. I can do that. So I think we plugged in 1 and we got 5. We plugged in 10 and we got 23. So any question why this one on the left is a function and the one on the right is not? Okay. And we'll come back to this one that's not a function in a little bit, and we'll draw it on the calculator. And you'll see when you draw something that's not a function, it has a certain look to it. That's basically another way of saying what I've already said to you. Domain, those are the numbers you're allowed to plug into a formula, and range are all the answers that you get back. Domain is generally pretty straightforward to figure out. Range can be a little bit harder, and that's where we're going to use the graphing calculator. Okay. We are working in the real number system. So unless the problem says otherwise, we have to work with real numbers. What kind of numbers are not real numbers? Yeah?
Imaginary numbers?
Perfect, imaginary. And that's just not something we're going to deal with right now. Okay, so let's talk a little bit about domain. So with domain, there are two things that can come up that we have to be careful about. So you can put this right under here. I don't have enough space, so I'm just going to make a new page, but you can just write it right where you're at. So two issues. To look for when finding the domain. Okay, first issue. In math, there's something we are not allowed to divide by. What is it that you can't divide by?
Zero.
Right, you can't divide by 0. So that's one of the issues. Dividing by 0. So how could that happen? Well, here's an example. Let's say you had 3 divided by x minus 5. You can plug in any number you want for x, and it'll be okay, except for one specific number. What number would you not be allowed to fill in right there?
5.
Right, you could not fill in 5. So if we were going to describe what numbers you can fill in, you could say all real numbers except 5. So the domain in this case, all reals except 5. You can plug in 4, you can plug in 3, you can plug in 8.2, anything you want except 5. Okay, so that's one issue you need to look for when you're finding domain. Make sure you do not plug a number in that would cause you to divide by 0. And if there is a number that would cause you to divide by 0, tell me what it is and tell me not to use it. Okay, second issue. Second issue is with square roots. We do not want to take the square root of a negative number. And it's not that you can't do it, but I said earlier, we are working with real numbers. If you take the square root of a negative, that's imaginary. And that's, for now, something we don't want to deal with. So square roots of negatives. Here's an example. Square root of x plus 2. You can plug in any number you want for x as long as this is a negative. That means this has to be 0 or higher. A lot of people, I think they mix up dividing by 0 with taking the square root of 0. You can't divide by 0. That gives you an error. But you can take the square root of 0. That's perfectly fine. No issue with the square root of 0. We just don't want to do the square root of anything smaller. Okay, when we try to do the square root of something smaller, it tells us it's not a real number. Okay? So you want to make sure that this is greater than or equal to 0. That's what we want to make sure of. Okay. Just make sure it's not negative. Now, to figure out what that means x could be, I'm going to solve that. How would I get the 2 over on the right side?
Subtract it.
Yep, I'm going to subtract it. And I get x is greater than or equal to what number?
Negative 2.
-2. That's the domain. You can pick any number you want for x as long as it's -2 or higher. Okay. That's the domain in this one. All right. Let's say you pick something that's not -2 or higher. Pick -3. What's -3 plus 2? -1. And if you try to take the square root of -1, it's going to tell you that you don't get a real answer. Okay. So those are the 2 issues we have to look for when we're finding domain. Make sure we never divide by 0, and make sure we never plug in a number that would cause us to take the square root of a negative. Any question on those 2 things? Now, mathematically, those are the only 2 things we can't do. When we're doing a word problem, there might be other things we can't do because of the word problem. For example, let's say, if we go back to that rent-a-car problem, x was the number of miles that we drove. Practically, it wouldn't make sense to drive what kind of number of miles?
0.
You could drive 0. That might mean you just book the car, you pay for the reservation, but you, for some reason, you never pick it up. You don't drive it. So you could drive 0 miles, but you couldn't drive, you couldn't drive -miles, right? Now, it's not because mathematically you can't do 0.2 times a negative number. You definitely can do 0.2 times a negative on your calculator. But in the context of the word problem, negative mileage doesn't make sense. Right? Another example might be if you were buying like tickets to a concert and you had a formula to figure out how many tickets you could buy. You can't buy a decimal amount of tickets. Right? You could buy like 6 tickets or 7 tickets, but it doesn't make sense to buy like 6.2 tickets to the concert. So when we're doing a word problem, we might have to be careful about what makes sense practically. Right? But these are the 2 things we have to look for mathematically. Right? All right. Now, so far I've been writing functions with y equals notation, but there's something else you can put instead of a y. Okay? The right-hand side would stay exactly the same, but it's a different way of writing the left side. Yep?
Oh, f of x.
Yeah, you can write f of x. And that's how you pronounce it, f of x. What this notation means is that letter right there is the name of that formula. That's formula f. Okay. This letter right here is the independent variable. So that's the name of the formula, and that's the variable that the formula uses. Okay, so if I wrote something like g of x, whatever I put on the right-hand side, the name of that formula is formula g, and the variable in the formula has to be an x. Okay. But you could do an f, you can do a g, sometimes you see an h. You can name the formula whatever you want. Generally, it's always named with a lowercase English letter. You might not want to use letters that look like numbers, like naming a formula O of x. O could look like a 0, and that could lead to some confusion. But F, G, H, those are all common words. Any question on that notation? F of x. Okay. We just talked about those 2 issues. Okay, so let's look at this one. So find a complete graph. That means we're doing it on the calculator, at least for that part. And then they want us to figure out the domain and the range. Okay. F of x equals the square root of x minus 3. Okay. If you look at that formula, Does that formula have one of the two issues in it that I said we need to be careful?
Yeah.
Yeah, which issue does that one have? It's got the square root. Yep. So anytime you got a square root, that's one thing we have to be careful about. So let's start with the domain. What number or higher does x minus 3 have to be?
3.
Well, let's just start out with pretend like you can't even see what's under there. Okay, pretend like it's just like a black box, like that. That black box has to be what number or higher?
0.
Yeah. So whatever's in that black box has to be 0 or higher. Now we have to look at what's in there. X minus 3. That means x has to be what number or higher?
Equal to 3.
Yep, so that's your domain. X has to be greater than or equal to 3. Now, the reason I did that first is because when I set my window on my calculator, now I know that I don't need to go all the way to -10. Right? If we do a standard window, it's -10 to 10. I'm just going to go to 0. Okay, I don't need to go negative because this graph doesn't go in the negative direction. But now let's see if we can graph that. So if you have anything else that's in there after you press y equals, we'll clear that out. And square root button is second, and then the 5th button down on the left-hand side. Okay, it's been a few days since we've used that, so everybody will be able to get that. Okay, so now, before we graph, we always go to our window, make sure everything looks good. We don't need to go all the way to -10. I'm going to go to 0, so that's a little bit of extra space past 3, but not too much. Let's leave x max. Let's leave that at 10. And let's just leave everything else the same. Okay, so let's just leave our window for the y's, min and max, -10 to 10. Let's hit graph. Okay, and that's a good graph of that square root function. Yes?
How do you get an x?
To get the x, you press the button right below mode. It's in the second column, second row from the upper left. And that is pretty much what all square root functions look like. Right? They have a point where they start, and they kind of curve in one direction. Now, watch what happens if I graph. Again, don't do this on yours. Just watch it on mine. I'm going to graph the negative of it. What shape does that kind of look like? Yeah, and that's what a square root function is. It's half a parabola, because you don't see the bottom part, on its side. Okay, that's a square root function. It's a parabola on its side. So I'm going to get rid of the bottom part. So the important thing that you can see with a square root function is where does it start and the direction that it curves in. Okay, so for our window, remember when you do a complete graph, you want to write down the window. And you don't need to write all those numbers. You just need to write the x min, x max, y min, y max. Okay, so there's the complete graph. Okay, so we've got the domain. Last thing, range. Well, domain looks at the graph left to right. It explains to you how far left and right it goes. This graph starts at 3, and it goes to the right forever. Range describes the up and the down. So let's look at our graph. If you look at how far down the graph goes, what does it look like the lowest it ever hits is?
0.
Yeah, 0, and it hits right here. And now if we could keep zooming out, how high is that graph going to go? Forever. It's a parabola on its side, and the parabola just keeps getting wider and wider and wider as you go further and further to the right. So it's never going to stop going up. So the range is every number from 0 and up. And just make sure you use y. Y is for range, x is for domain. Okay, and if you don't know what a square root function looks like, it can be a little hard to find the range. Even if you do know what it looks like, sometimes it's easier to just look at a picture to help with the range. Okay? And that's generally how I will always do it. I'll look at the picture to get the range. Any question on that? Okay. All right, so find the domain and the range. So remember, domain are all the numbers you are allowed to fill into x and not do something you shouldn't do in math. Okay, let's look at this one. Y equals x squared minus 4. Two things we got to be careful about. Square roots, divide by 0. Does this problem have a square root in it? No, so we don't have to worry about that. Does this problem have a fraction with a letter in the bottom of it? No. So the two things that could be an issue are not in this problem. So what do you think that means the domain is? Yep.
All real numbers?
Yep, all real numbers. Mathematically, you can take any number you want and raise it to the second power. You can raise negative numbers to the second power, decimals, zeros, fractions, anything you want can be raised to the second power. All right, now, let's do, did they ask for a window? No, just domain and range. Okay, so let's type in x squared minus 4. X squared minus 4. Okay, I'm going to leave the window the way it was. I'm not sure that that's going to be a good window for this problem. But let's just leave the window. Let's hit graph. No, that's not a good window. When you raise something to the second power, it's supposed to look like a parabola. That's a U shape. If you can't see the U shape, that's not a good window. So let's do zoom, and let's reset it. Does anybody remember the window that we normally use? Zoom, what is it? Zoom 6, yeah. That's just kind of a starting point. I'm not saying that's going to be a good window either. Maybe not. But I just want to reset it so I can start over. So zoom 6. And actually, that's perfect. That's a good window. Because now I can see the U shape of the parabola. Okay, so when you're graphing a parabola, it's important you can see that it's symmetrical and where it bottoms out. Okay, so we've got the domain, all real numbers. This parabola is just going to keep going left and right forever. Okay, how about up and down? Does it go up forever?
Yeah.
Okay, does it go down forever?
No.
No. Then that means somewhere it hits its lowest point. What's the lowest value that it looks like it hits?
-4.
Yep, -4. So the range in this one is every number from -4 and up. Yep. That's the range, everything from here up. And what letter do we use when we write the range? Y. Yep. Okay. So there's your domain and range. Any question on that one? Now, we're going to graph almost the same one again, but the point is I want to show you on the calculator how you type in an absolute value, because I'm not sure I've shown you that yet. So I want to put absolute value bars around what we just typed in. Okay, easiest way is we're just going to retype the whole thing. Okay, so we're going to go to y equals. And to type in absolute value bars, you press math, and then you're going to press the right arrow until you highlight the second menu over that says number. The first option in that menu is ABS. That stands for absolute value. So you press math, press the right arrow, and it's option 1. If you press that, you'll get a pair of absolute value bars on the screen. Now, what does absolute value do to a number? Or
Makes it positive.
makes it positive, or there is one number you can take the absolute value of and it doesn't come out positive. 0. So absolute value at least makes sure it's not negative. That's what absolute value does. Make sure it's not negative. Might not be positive, but it definitely won't be negative. So where that parabola tried to dip below the x-axis, absolute value is not going to let it do that. So let's type that in, hit graph, and watch what happens when it tries to go under the x-axis. It's almost like it just bounces right off it. All right. So this part right here was originally down there, and the absolute value flipped it up, so it can't go negative. Okay.
So would your range be y is greater than or equal to 0?
Yep. So now the range doesn't go down into the negatives. It's greater than or equal to 0. And what effect did that have on the domain?
It's not all real numbers.
It's still all real numbers. Right? You still aren't taking the square root here, and you're not having a fraction with a letter in the bottom. So we didn't affect the domain at all. Okay, but again, the point of that was really just to show you how to type in absolute value. Any questions on that? All right, so what does it mean to evaluate? Evaluate means I'm going to give you a number, I'm going to give you a formula, and I just want you to take that number and plug it into the formula. Or I could give you a letter too. Basically, whatever I give you, plug that into the formula. So in this case, the formula I'm going to give you is x squared plus 1. Right, so that's the formula, and I'm going to give you some different things to plug in, to substitute in for an x. And I just want you to tell me what the answer would come out to. Let's try these three. So let's start with f of negative 2. So these are 3 separate problems. Okay, we're going to do them each one at a time. That means everywhere that we see an x in the formula, we're going to change it to negative 2. So put that in right there. Okay. So when I fill in negative 2, I'm going to have negative 2 squared plus 1, which would give me how much? 5. Yep, that's going to give me 5. Now let's try it on the calculator. And again, this is to show you a couple things. First of all, reminder, when you type in a negative number, a negative is below the 3. The negative is not over on the right-hand side. That's a subtraction sign. Okay, so negative 2 squared plus 1. Perfect. Gives me 5. Now, how come when I do it this way, it doesn't give me 5?
Because the negative is not a part of the square.
Right. Okay. When you square it without parentheses, what you're telling the calculator to do is take 2, raise it to the second power. That gives you 4. Throw a negative in front of it. That gives you negative 4. And then add 1. That gives you negative 3. So the calculator is following order of operations. It is doing it correctly for what you said to do. But if you want to raise a negative number to a power, I would recommend putting it in parentheses. Okay. Any question on that first one? All right, let's try f of a. What would the formula on the right-hand side look like? if I plug in a where the x is.
A squared plus 1.
Yeah, that's not one that you can simplify numerically. That's all you can do. It's a squared plus 1. All we did was fill in the a for the x. Any question on that one? Okay, and the last one. Let's do it down. Christian, when I fill in the x minus 3 for x, can you just show me what it's going to look like, and then we'll simplify it in the next step.
It'll just be x minus 3 and then left side of x minus 3.
Yep, so let's do it like this first. So yeah, x minus 3 squared, and then what's after it?
Plus 1.
Plus 1. And then what did you say x minus 3 squared means?
You just do the equation 3 times like, together. So then you would have to distribute it.
Yeah, so we're going to write x minus 3, x minus 3. And that is something we can simplify. Okay, so you have to distribute it, double distributive or FOIL. Some people learn it that way. What's x times x going to give me?
X squared.
X squared. What about x times negative 3?
3x. Negative 3x.
Negative 3x. X times negative 3. Another negative 3x. And negative 3 times negative 3. Positive 9 plus 1. Okay. Now we just have to combine everything we can. There's nothing to combine with x squared. How about negative 3x minus 3x? Minus 6x. So that's gone. And 9 plus 1? 10. And there you go. So any question on plugging in either a number and evaluating or a variable expression? Okay. So I told you earlier that not all equations are functions, right? That if something's a function, that means when you plug one number in, you get how many answers? Exactly 1. That was the, let me write down the one that I showed you was not a function. That's an example of something that is not a function. Okay, so let's, let me type that in. You can just watch me type this one in. Square root of x. And I don't have a plus or minus symbol. I have to type it in as 2 separate graphs. Positive square root, negative square root. Okay, so there's your positive, and here's your negative. So we know that if you plug in one number for x, you're going to get 2 answers for y. What that means visually is it fails the vertical line test. When you draw a function, if you can put a vertical line anywhere and it hits the graph more than once, then you do not have a function. So if it hits the graph more than once, it's not a function. So let me put up some different pictures, and we'll just identify if they're a function or not a function. How about that one? Nope, that's not a function. Because you can put a vertical line, and it hits more than once. How about something like, let's do this one. Is that a function or not a function? Yeah, that's a function. You can take a vertical line, and no matter where you put it, it's never going to intersect that blue one more than once. Okay, so yeah, that's definitely a function. Let's look at something like this. Let's do this graph. Okay, so same question. Is that graph a function or not a function? Yeah, that's a function. No problem at all with that one. Right? No matter where I put this vertical line, well, if it was in front of it, it never hits the graph more than once. Okay, so that is a function. All right, let's do one more. Let's do this one. And I might have to zoom out a little bit so you can see that better. Okay. Function or not a function? That's not a function. Definitely fails the vertical line test. Okay. What's that? So to get a spiral, we've got to do a different kind of graphing. It's, if you notice, it doesn't say y equals anymore. When I go here, it says r equals. So it's something a little different I did. But yeah, doing it this way, we can actually get all kinds of things. I don't want to spend a ton of time. You probably can't even see that. Let me zoom in. Zoom 6. You still can't see it. Zoom 2. There you go. All right. So definitely not a function again, because it fails the vertical line test.
That's pretty.
Yeah, it's like that's like an 8-petaled rose. That's the name of that particular shape. Yeah. All right. So any question on what the vertical line test is? All right, so this one, let's see. Find a complete graph. All right, so they want a window, and then determine the domain and the range. All right, so 16x minus x cubed. Before I even graph it, I'm going to do the domain. Anyone have a guess what the domain is here? Yep.
Would it be all real numbers?
It's all real numbers. Are there any square roots in that problem? No. Are there any fractions with letters in the bottom? No. So the two things that are an issue for the domain are not in that problem. If they're not there, then your domain is all reals. Okay, range, well, that's a little bit harder, so for that, we will graph it. Okay. So we're going to type in 16x minus x cubed. The exponent button, if you aren't sure where that is, it's on the right-hand side, right above the division sign. And that'll give you an exponent. Okay. If you had more to type, and you keep typing right now, it's going to stay in the exponent. If you want to get out of the exponent, you can press the right arrow. And now what I type is not in the exponent. Okay. So now I have to go fix all that. Okay, so 16x minus x cubed, and let's try zoom 6. Okay, do you think that's a good window? No, it looks like something's happening off the screen. It's probably connecting here, but we can't see it. So which two values do we have to adjust to see a little higher and a little lower?
The y max and the y min.
Yep, let's try adjusting the y min and the y max. We might not know what to adjust them to. So we could just try like negative 70 to 70. See what happens. Let's see if that looks better. That's good. That is a complete graph. Okay, so we haven't learned a lot about graphing things that have an exponent of 3 yet, but that is a very typical looking graph. This part will continue that way, and that part will continue that way. It is not going to turn again. And there's a way that I know it's never going to turn again, and we'll talk about that. What's that? It's because it's a 3. When I see a 3, that means if I subtract 1 from that number, I get a 2. That's the maximum number of times the graph can turn. It's 1 less than that number 3. And I can see both turns on the screen right here. So it can never turn again. That just goes down, and that goes up and to the left. Okay, so what does it look like the range is going to be?
All real numbers.
That's also all real numbers, yeah. In fact, any polynomial that has an odd number right there will always go up forever and down forever. Okay? And we'll learn some of those patterns as we go. But yep, this one is all real numbers. You can write all reals. That's the same thing as all real numbers. I did not give you the window, but it did ask for that, so there's your window. X min x max, y min y max. Okay. Any question on that one? Okay, let me just see what we have left. All right, not much. All right, so this one, this is a word problem, and I basically written down just the important information from it. So this is example 9 in your book on page 28. Okay, we have a rectangular pool, and the pool has dimensions 30 feet by 50 feet. There's also a sidewalk all the way around the pool. The sidewalk is the same width all the way around. We don't know the width of the sidewalk. That's what they want us to find. But they do tell us the area of the sidewalk is 600 square feet. And they want us to somehow use all that information to find the width. Okay, so there's a lot of information there, and it's all in like sentence form. What would make this kind of problem easier for someone to think about, rather than having all these sentences?
Write it out or draw it out.
Draw it out, yeah. Let's draw it out, and I think that'll give us something to think about that's a more visual and less words. All right, so one thing we definitely need is the swimming pool, and there's a sidewalk around it. All right, so let's start with that. So here's our pool, and I'll put a sidewalk around it. Okay, so inside here, that's the pool. And it said the dimensions of the pool are 30 feet by 50 feet. So let's go 30 by 50. Now there's a sidewalk all the way around the edge, and we don't know the width as a number, but what letter did they give me to represent it? X. So that's X, and that's from here to there. And it's the same thing over here. From there to there. That's the width of the sidewalk.
You have to find the area.
Yep, so we got to do something with the area of the sidewalk. So I'm going to write that down over here. Okay, capital A just stands for area.
You have to find the area of the pool.
Okay, so we could definitely find the area of the pool, and that's going to be important. It's a rectangular shape, and how do you find the area of the pool in this case? 30 times 50, so that's 3 times 5 with 2 zeros. All right, so now we've got to come up with an equation. So imagine that I gave you a piece of paper, right? And I said to you, I want you to give back to me just the sidewalk section. If I gave you this whole piece of paper exactly the way it looks right now, and I said, just give back to me the sidewalk part, what would you have to do? You'd have to cut out the inside. You'd have to subtract out the pool. Okay? So if you want to get the area of the sidewalk, okay, just the strip around the edge, you'd have to take the area of the big rectangle and you'd have to cut the pool out of it. In math, what operation do you think represents cutting the pool out of the picture? Yeah?
Subtraction?
We're going to subtract it. Yep. So we'll take the area of the big rectangle, which we don't know, and we're going to cut out.
So you add the two and then find
Yeah. So let's fill in everything that we know. What's the area of the sidewalk? 600. That was given. What's the area of the pool? 1,500 wasn't given, but it is something we found. Now we need the area of the big rectangle. Just to be clear which rectangle I'm talking about, I can make it a different color. Let's make it like the, I don't know, it's the purple rectangle. Okay, so I need the area of the purple rectangle. What's the formula for area of a rectangle? Length times width. Length, width. First thing I need is the length of the big rectangle. Well, we know from here to here on the big rectangle is 50, right? Because that part lines up with the pool.
x squared.
And how big is this section over on the left?
X.
And this section on the right?
X.
What's x plus x?
Squared.
Or 2x.
2x. So the entire length of the bottom side is 2x plus 50. So that's the length. And the width, same idea.
2x plus 3.
That part's 30. That part's x. That part's x. 2x plus 30. Yep. Okay. Now this is something we saw earlier where you have to distribute. So we'll distribute that. 2x times 2x gives me 4x squared. What's 2x times 30?
60x.
I'm just going to put that off to the side for a second. What's 2x times 50?
100x.
100x. Add them up.
160x.
160x. And 50 times 30, we already know, we did that earlier, is 1,500. So that's 1,500, but then those two are always going to cancel out. Yep. And now we have that equation to solve. Okay. What's the highest exponent in that equation?
2.
It's a 2. And does anybody remember what you call an equation that has a highest exponent of a 2? It is a polynomial, but it's not linear. Linear would be a highest exponent of 1. It's not cubic. That would be a highest exponent of 3. It's in between.
Binomial? Or
Squared, which begins with a Q. It's a quadratic. Yep, that is a quadratic equation. So reminder from Algebra 1 and 2, if you want to solve a quadratic, you've got to get it equal to 0. That's what you have to get it equal to. So how would you put that 600 on the other side?
subtract it.
Yep, subtract it. And does anybody remember the name of the thing that you can use to solve a quadratic equation? Well, one method is to try to factor, but I don't think this is going to factor because the answer is it's not going to be a nice number. Yeah?
Can't you take the number that's in the middle and find find two numbers that add to make the number that's in the middle, but multiply to make the number that's on the right side?
If it was factorable, yeah, you'd be looking for something like that. But I'll tell you, the answer comes out to decimals here, so you're not going to be able to use that method. But some problems you could, just not this one. Does anybody remember the other thing that you can use, the something formula? Yeah?
Is the quadratic formula?
Yep, quadratic formula. So before we even use the quadratic formula, if you look at all those numbers, you can make them smaller by dividing them by something. Does anybody see what they're all divisible by?
4.
Yeah, they're all divisible by 4. You don't have to do this step, but it will make the numbers easier to work with. Okay. And now, quadratic formula, in case we don't remember what that is. Does that look familiar now? A little bit? Okay. It's not that hard of a formula to use. You just have to know where the A, the B, and the C are coming from. Does anybody know what the A is going to be in this case?
X squared.
They're all numbers, A, B, and C. Yep. It's the number that's in front of the x squared, which is a 1. How about the B?
40.
40. And the C?
Negative 1.
Negative 150. Yep. Okay. So let's plug those in, and then we'll use the calculator to see what we get. So we have negative 40 plus or minus the square root of b squared, 40 to the second power. 40 times 40 is 1600. Minus 4, then I need A and I need C. There's A, and there's C, and that's all divided by what?
2A.
2A, which is 2 times 1, 2. Now, under the square root, we're subtracting a negative number. What happens when you subtract a negative? It turns into a positive. So if we want, we can make that positive right now, because it's going to become positive. What's 150 times 1 times 4?
600.
Yep. So this part over here is 600 plus 1600.
2400.
2200. And there's our answers. Now we got 2 answers. We have one with plus the square root and one with minus the square root. Now this problem is about the width of a sidewalk. Width is a distance. What kind of number does distance have to be? Positive. So probably one of these numbers is not going to make sense. Okay? It works mathematically, but it will not work as far as the width of the sidewalk. So let's try negative 40 plus the square root of 2200 and divide by 2. So we get about 3.45. That's okay. That's a positive number. And that could be the width of the sidewalk, a little over 3 feet. Sure. So I'm going to put x is about 3.45 feet. Now, there shouldn't be another answer to this problem. We already have an answer. So there's going to be a problem with the next one. Negative 40 minus the square root of 2200. I don't even need to keep going because I just got negative 43 feet for the width of the sidewalk. Does it work mathematically? Yep. Does it work in the word problem? No. Okay. Any question on that one? So I'd say the biggest thing that will really help you is making a diagram. Then it makes it a lot easier to see what's happening. And that was a little bit of a reminder about quadratic formula. So if you don't remember that, you may want to write that formula down. And it is something you can put on a reference sheet for a test. Okay, any questions on that one? That was that's the hardest one we do today as far as a word problem. All right, so last two things. That's just on the calculator. That's very easy. Okay, projectile motion. So projectile motion, we don't have to know a lot about it as far as physics go. All we have to understand is there's a formula we can use to answer a question about this kind of motion. That's all we need to know. And here's the formula. Okay, there's a few variables. First of all, what does this formula give you? It tells you how high an object is going to go. So basically, if you take an object and you throw it, how high does it go? That's what it's telling you. So this part is the height. Any guess what the T might stand for? Time, right? Because if you want to know how high this object went, well, it depends on what time you're looking at it. Was it a tenth of a second after I threw it? Was it half a second? Right? So T is your time, which, I mentioned T is seconds up there, so that's your time. This V sub 0 is how fast you threw the object. So that makes a difference. Did you throw it really gentle, or did you throw it a little bit harder? And what was the height when you released it? Did you throw something off the ground when it started? Or were you on top of a building when you threw it? That makes a big difference. So in our problem, we use units of feet and seconds. In other science classes, you probably use metric. Okay, but we use feet, seconds in that form. Okay, does everybody have that formula? So here's the information they give us. It says that you're shooting a rocket straight up from ground level, and the initial velocity, the initial speed of the rocket, is 64 feet per second. Okay, so first thing we should do, even if we don't know what they're going to ask us yet, but we should put all that into the equation up above. So the height of the rocket equals, and what always comes right after the equal sign in this formula? This part never changes.
Negative 16t squared.
Yep, negative 16t squared. They didn't give me a time yet, so I have nothing to fill in for that. But they did give me an initial velocity, 64. So we're going to fill in 64 right there. So it's going to say 64t. And they did tell me one other thing. Ground level. Right. So the initial height of this rocket, it wasn't shot off a building or anything. It was on the ground when it was launched. So plus 0 for the initial height, but you don't need to write that down. Okay, so here's a formula. Don't know how we're going to use it yet, but that represents the word problem. Any question on the two things we filled in, the 64 and the plus 0 that we don't need to write? Okay. So it says, at what time will the rocket be 50 feet above the ground? That 50 feet, that represents the what of the rocket?
Height.
That's the height. And height goes on that side. So what we're going to do is we're going to fill in 50 where it says S of t. Take that, fill it in right there. Okay, nothing happens on the right-hand side. Okay, that stays exactly the same. Negative 16t squared plus 64t. Okay, now, what kind of equation is that? It's another quadratic. And what do we always want to get it equal to? Want to get it equal to 0. Now, I just went through quadratic formula, so I'm not going to do that again. What I want to do this time is type that in on the calculator. Negative 16t squared, but remember, you have to use x, you can't use t. So let's type that all in. And what we're going to do is use the calculator to give us an answer. And you know what? Actually, I think it's going to be even easier. Let's type it in like it is on the top one. Okay. The bottom one would be good if we were going to use quadratic formula, but since I'm not doing quadratic formula, I don't even think there's a need to bring the 50 to the other side. So I'm going to leave it the way it is in the top one. We're going to put 50 on one side, and then negative 16t squared plus 64t on the other. Doesn't matter which side you type in first. I already started typing the right side, so I'm going to just put that in the top one and put 50 in the bottom one. Just put one on one, one on the other. What kind of number can time never come out to? Can't come out to negative. How about height?
Maybe negative.
That can't be negative either. So when we set our window, we shouldn't be looking at negative time, and we shouldn't be looking at negative height. I'm going to leave everything else the way I had it. What's that?
In this case, height couldn't be negative, but height could be negative. No.
Right, so yeah, we'll just think of it as like above sea level kind of thing. We're not going to launch rockets into the ocean or anything. So we're not going to go below sea level. Right, so it's always 0 or higher. Let's hit graph. Actually, that's a good window. So there's the height of my rocket, and there's 50 feet. Why does it look like the rocket hits 50 feet twice? Yeah, because it goes up and it goes back down. So there's 2 times where the rocket hits 50 feet. And last week, I think we talked about, did we talk about how to find an intersect on the calculator?
Yeah.
Yep. So we're going to do second calc intersect. I'm going to press my left arrow until I eventually see my cursor. There it is. I'm going to put it near the one on the right, and I'm going to hit enter 3 times. That is the first time the rocket hits 50 feet. Oh, I'm sorry, second time. That's on the way back down. 2.94 seconds. That's one answer the quadratic formula would have given you. Here's the other one. Second calc, intersect. This time move my cursor over closer to that one. And hit enter 3 times. That is the second one. 1.06 seconds. And both answers make sense. Unlike the sidewalk problem, we want both. Okay. Any question on that? Okay, so last question. What is the maximum height of the rocket, and at what time does it hit it? Again, we're going to use the calculator. Which curve there is going to help me to answer this question? The red one or the blue one? Yeah, I don't even need the red one. Okay, so if I want, I could get rid of the red one. Just need the blue one. And we want to calculate the highest that the rocket ever goes. If you press second and you press trace, there is an option there that will help you figure that out. Anybody have a guess which option it is? Maximum, yep. Have we ever done a maximum? Have I shown you that? Nope. Okay. Very simple. So you pick option 4. Now, my cursor is way off the screen. If I press the left arrow, I can see it heading up towards 0. I have to see my cursor to do this. There it is. Okay. The first question it asks you is left bound. That means take your cursor and put it somewhere to the left of where you think the highest point is. Once you put your cursor where it is to the left, hit enter. Now the next question it asks is right bound. So take your cursor and put it somewhere to the right of the maximum and hit enter. And what it has now is it has like this zone it's going to look in. So it's going to say between the dotted lines, what is the highest that it goes. The guess doesn't matter. If you want to put it close to it, you can. Looks like it's about right there. And then hit enter one more time. Okay, so let's see what it gave us. Let's see if we can interpret what that means. How high do you think the rocket goes? Yep, max height. That's the Y value. That's the height. 64 feet. And we're going to round our answer because remember, it's 2 seconds. Yeah. So the max height is 64 feet. And I'll just say this happens at 2 seconds. Okay, so that's called the maximum feature on the calculator. Okay. Any questions on that? All right, so that's most of 1.3. There's one thing we didn't do. It's the easiest thing on the calculator. It's kind of like finding a maximum in terms of the difficulty. It's very easy, but I'll show you tomorrow. Okay, so let me just take a look and let me take off the question that we didn't. Page 30, the 3 to 19, that's just odds. So it's 45. That's the only one we didn't get to. Okay, so what we'll do is we'll do 45 together tomorrow when we go over the homework. Okay, so 3 to 19 odd, 24, 32, 33, and 50 to 52, that's all. And I think 50 to 52, it's like a swimming pool problem, except they say you have a photo, and you're putting a border around the photo. It's exactly the same question as the swimming pool. All right, so we will take a look at that tomorrow.